Yeah. That one would be fun. You know,
Yeah,
using
I was
that.
looking forward to that. I'm disappointed we're doing the tic-tac-toe because that's too easy.
Do yourself in the free time.
Yeah. Well, I don't have much free time, but I want to practice it so I know it. This summer I have to teach myself physics because I think I'll be taking that soon.
All right. Only with 2 people, but that's good.
I just bummed out because the projects are too easy. When they give them to us, I'll spend maybe 2 hours.
Okay, so good. Actually, it doesn't help you much because you guys are all sitting in front of the speaker.
Yeah.
All right, so let's take a look at the questions. And they're all on my Google Drive. Makes me wonder, whether someone can actually hack into my Google Drive and look at all the exam questions.
Sounds like they should get an A if they pull it off.
Exactly.
You're like, well, you obviously get this class.
But they can also hire someone to do it.
True.
All right, so this is the first question. The first question is not too bad, I hope not. So you just have to go through the whole thing and just double check everything.
Right.
So in the C code, we have A as a pointer to a const int, or an array of const ints, and the second parameter is n. It returns an integer. So we already know in the C code that we have 2 parameters, each one is 32 bit wide. So in the assembly code, I start with the usual stuff, which is old EBP equal to 0, and then I make this mistake of return address is 0. Okay, catch this one, make this old EBP plus 4. Or if you want to just say 4, that's fine too. Okay, but this line needs to be fixed. The next 2 lines are wrong as well because A is the first parameter. That should have the lower address. So A should be return address plus 4, and then N should be A plus 4. Or if you spell out the constants, that would be acceptable as well. But they need to be addressed. Okay? Is that okay so far?
So,
But there are lots of things that are wrong with this program. So missing a few things doesn't mean it's the end of the world.
so you're saying A would have gotten pushed on the stack first?
Say, huh?
A would have been pushed on the stack first?
No, N is pushed first, and that's why it has a higher address. Remember, the stack grows in a reverse order.
Right.
So because N is the second parameter, it is supposed to have a higher address, and it's the one with a higher address. That means A is the one that is return address plus 4, and N is A plus 4. So these 2 lines, these 2 variables are flipped. All right, moving on. We have the sorted label, that starts, and we have a return instruction at the end. Okay, so that part is that should be all good. And then we go into the subroutine. Into the subroutine, we have push EBP, move out ESP to EBP, and then to end we have the opposite, which is move out EBP to ESP, but it's missing the pop instruction. Yep. Okay, so that's the other error. Okay, so into the function itself, the first thing we want to do is to compare 1 to n. So I'm comparing 1 to n in parentheses EBP. And to j, a to else means that if n is greater than 1, we jump to else. However, because n is assigned integer, ja is the wrong conditional branch. It will only work in half the cases, but it will fail the other half cases. So the proper one to use is a JG instead of a JA. Okay. So we jump to the else case if n is greater than 1. Otherwise, we want to copy a 1 into result, and I put a 0 into result. Right. So there are 2 things wrong here. 0 needs to be, whatever is the first operand needs to have a $ because it's an immediate operand, and it needs to be a 1 instead of a 0. So there are 2 things wrong here. If you catch 1, then you get partial credit. If you get both, you get full credit for this. And it jumps to end if because this is the then branch. It has to jump around the else case. Except there's no end if defined, so you have to define end if to this place here.
Else done.
Else done would be fine as well. So you have to define it here. So you have to define end if. Okay, so here's the else case. Yep.
If we, instead of defining end if, we just changed end if to else done.
That would be fine. Just one way, just a way to fix it. Okay, so now we have else, and the else case needs to compare a bracket 0 and a bracket 1 first, and then depending on the result of the comparison, we'll decide what to do. So the first thing we need to do is to load a into EAX, which is the correct thing to do. Nothing wrong with this one. And once we are done with this instruction, EAX is going to be the same thing as A, which is a pointer to a const int, which is also known as the beginning of an array. Now, if EAX is pointing to the beginning of an array, 0 in parentheses EAX refers to the first element, and then 4 in parentheses EAX refers to the second element. So the operands themselves are actually correct, but they're both memory operands, so we cannot have both of these in the same instruction.
Right.
So you have to break them up. So you have to move one into a register. We'll use EDX since it's disposable, and then compare it to the second one.
Well, that didn't you also have to? Oh no, you did with the 4.
And then we have a JG0, which means if the result of the comparison is a 0, then we have to go to the label 0, because in that case, we have to end up with a 0 in result. So that part is actually correct. Is that okay or not?
If it's greater than 0, isn't it JG?
If the first element is greater than the second element, it means it is not less than or equal to. So that also means the result needs to get a 0. So that's why it branched to here with a JG.
Since we,
huh?
I was gonna say, if we somewhat rewrote that.
What?
If we rewrote it, because like the
If you
compare long, since the compare long had to get fixed, and I realized that
you have to fix this one.
Right. So what I did was I actually incremented EAX by 1, because EAX also gets pushed for the next call, and then I had to compare EAX minus EDX.
You cannot just add 1. You have to add 4 to it if that's what you want.
I added 1 to the memory address, or is it 4 to the memory address? Okay.
You have to add 4 to it.
Okay.
Okay, so this is basically corresponding to, what if a bracket 0 is actually less than a bracket 1, less than or equal to. So this is definitely wrong because it's not actually pushing n and then subtracting 1 from it. There are several ways to do it. You can push n in parentheses EVP on the stack and then subtract 1 from whatever you just push on the stack. You can also copy this into a register, subtract 1 from the register, and then push it. So whatever you need to do, this instruction needs to be fixed by multiple instructions. There's no way to do it in one single instruction. The second one is pushing EAX on the stack, and EAX is already pointing to the beginning of the entire array, and we are just adding 4 to ESP or whatever ESP points to, and that's actually correct. That will actually push the address of the first element of the array on the stack. So we are not interested in the actual element itself. We want to push the address of the element. So these two instructions combined would actually get a trick none. So they are actually correct. Unless you do something here that messed up EAX, and EAX does not end up having that address anymore.
Well, my EAX just had the next one in it. So
Right.
I didn't need to add the extra 4.
Yeah. So then you call the subroutine, that's the recursive call. Whether it's recursive or not really does not matter. Okay, so you call the subroutine again. This part is wrong because we pushed 8 bytes on the stack as parameters. So the adjustment should not be 4, but 8 here.
Right.
And then we copy whatever the subroutine comes back, as a return value, which is in EAX, into our own result. And then we jump to else done, and else done is just the end of the entire subroutine, which copies the result back into EAX, which seems really kind of redundant, but I'm just mirroring the code here, so that will still be okay. There's no need to fix it. Okay, it is still okay. And the rest of the program should not have any problems. I already pointed out the one here.
Yeah.
With a missing pop L EBP. So is first question okay?
Yeah. Yeah, just
Yeah,
read a few
mostly
things.
just tedious, and you just have to be kind of thorough to check everything. Question number two. Question number two is asking you to implement the following function in assembly code so that it is C callable, which also means that you have to use the convention of using the stack to pass parameters. Include all the content of the source file to implement this function. Leave nothing to assumptions. Okay. So what
So
we'll
you mean
do,
like-
because some people may make the assumption that the labels are already properly defined, so don't make those assumptions.
No.
That's the whole point. All right, so let's go ahead and see what we can do here. So we start with the usual stuff, dot global post inc to export the label itself, post inc and then a return. But since you cannot do this, on a piece of paper, it gets a little bit harder. You just have to leave some space in between. I usually just do this, but you do not need to. So if you just kind of hard code the constants in, that's fine. But personally, I just like to do this. Okay, so if you just say PTR equals to 8, it's fine.
Right.
Not a problem.
Same thing.
Same thing. And we don't have any local variables in this case, which is cool. So here we have push L EBP, pop L EBP, and then in between we have move L ESP to EBP. So the frame pointer becomes the frame pointer, and then we have EBP back to ESP.
Right.
Now, if you do some other tricks to get the same thing done, it's okay too.
Right.
For people who don't want to go through all of this trouble, you can pop everything and then re-push the return address and do all kinds of stuff like that. It's just not necessarily the best practice, but if that's how people want to get it done, hey, that's okay. So the next thing we need to do is to put the parameter itself into a register. That part is unavoidable because we need to change whatever it points to by increasing it by 1. Okay. Okay. So there are several ways to proceed at this point. Okay. You don't have to use the exact code. So the first version that I do is going to follow the exact code. Whatever the code does, I'm going to do it the same way. So we'll just end up adding a 1 to whatever EAX points to. Okay, that concludes the first line in the C code. On the second line of the C code, it's going to go back to that location, retrieve the value, and then subtract 1 before it returns. Okay, so it's kind of redundant, but that's basically how the code, the structure of the code is calling for. So I move L EAX into EAX, subtract 1 from EAX. That's it. So that's one way to do it.
I did that one perfectly. I did that one perfectly.
You did exactly that?
Yep.
Okay, excellent. So if you don't want to do it like this, there's another way to do this, which is kind of the lazy way to do
Might
it.
have been the way I went. I put the value in EAX and then I moved it to EDX and then updated it.
You could do it that way too. I don't even bother to blow another register. So what I do is I do a push L EAX in parentheses. So I'm pushing the value of at the pointer,
Right.
which is what I need to save. And then I do this part here, and I just pop everything back into EAX itself. I'm done.
Didn't go that route.
This is the lazy route, okay? Just push, pop, So, whatever you do that gets the job done, it's good, okay? So I'm grading this on, do you keep the stack balanced? Is the whatever being pointed to by pointer incremented by 1 and with a right width, and the function return the original value of whatever pointer points to, does it give it back to you? Those are the criteria. So as long as it is C callable and gets all of those things done, it's fine. Okay. All right. So that's question number 2. Anything you guys want to ask about question number 2?
When that gets converted down to like really low, it's like machine code. Does the computer care which way it goes? Like which way you do it? Is it one faster than the other?
Probably one way is faster than the other. This would not be the fastest way to do it. As far as execution time is concerned, this would be faster. Just copy into a register that you can blow, and then copy back here. That actually would be faster. Or, better yet, you copy this into the register that you don't need, copy that register, or copy indirect from that register into the actual result here, and then just add one to whatever EDX points to. Right. This will be the fastest code because it has the least number of instructions for one thing, and it doesn't make use of the push and the pop instruction. Each push has an implicit memory write just by itself, and then if you're pushing indirect EAX, you have two memory access, which makes it a very slow instruction. So this would be the one of the quickest instruction set to get it done.
I just forgot the label. I forgot the label.
You forgot the label?
The post 8. The colons.
Forgot the label?
I just forgot to put the label on the paper. Like I
oh, you mean global. These things?
Yeah.
Oh, so you make use of them, but you did not define them?
No. On global post 8 INC, I just forgot to put post INC colon.
Oh, this one?
Yeah, I forgot to put the label for it.
I probably won't really notice.
One can hope.
Okay, question number 3. Reverse engineer the following assembly code into C code and resolve types and nested control structures to your best ability. All right, so this one is about looking at the source code. Yeah, we got something like this in the other one already. So let's go ahead and check out how to get this one done. Okay. All right, so we know the name of the function is f, so I'm going to preserve that just so that it's easier to deal with. So we have some kind of return type, okay? So we have question mark as the return type. This is function f. We know that we have two parameters. The one with a lower address is the first parameter, and the one with a higher address is the second parameter. So the correct order is q and then p. We don't quite know what type they are. We just know that they're each 32-bit wide. And then in the subroutine, we have a local variable. R, because how do we know R is a local variable? Because it's on the other side of ODBP, okay? And in this case, I do have the adjustment for the stack pointer correctly, so it's all done correctly here. All right. So because this one is actually the correct code, people can actually use this as a template on the first.
Yeah, that's fine. I went back a few times to double check things.
And people who don't do that, it's like, well, I'm sorry, but I actually mentioned that in class that that you can use one of the questions to help you answer the other questions. Yep. All right. So the first thing we do is to make r equal to 0, which is this part here. Okay. So r equals to 0, has to be done first thing. And then the second thing we notice is we have a label defined before a branch to it. So that usually always implies there's a loop of some kind, especially when you see the branch is unconditional down here. So that makes it a while loop. So we have some kind of a while loop, and then we just need to figure out, okay, what is the condition of the while loop? The condition of the while loop would be all the stuff until we get to the condition, until the branch out of the while loop. L2 is the first label out of the while loop, so any branch to L2 is a part of the conditional branch. And we do have these two statements here, so these two are responsible for the condition of the while loop. The first statement, or the first instruction, moves Q into EAX, and then we compare whatever it points to with a 0, and this is a compare byte instruction. So right away we can solve a few questions, because it's basically saying if it is 0, we get out of the loop. If it's not 0, we stay in the loop. So that means if Q points to something that is non-0, we stay in the loop, because as soon as it becomes 0, we get out of the loop. At the same time, we also know that this is a char pointer, because it has a compare byte with indirect with EAX, and EAX has the value of Q at the time. So are we okay so far with this part here? We just resolved the type of Q. Is that good? Okay.
Did you ever consider a constant or just guess?
You can put a const here, but I'm not going to count any points against people who do not, point it out. Okay.
It just looked like it was a string.
And there's a reason why I do not, deduct a point here. Okay, so the next thing we do, once we get into the loop itself, is we push a 0, and then we immediately move indirect EAX into AL. EAX already has Q in it, and I'm moving a byte into it, and we just push we just put a 0 onto the stack as a 32-bit constant.
Right.
This is just sign extension, just turning into an integer. So we push this onto the stack, and then we push p on the stack, and then we call string char. Now you don't even have to remember what string char does, okay? Because you just say, okay, it's a function called string char. It has 2 parameters. The last parameter is pushed first, so that would refer to whatever q points to, but as an integer. And then the first parameter is whatever is pushed last, which is p. Are we doing okay so far with this? Is that good? Okay. All right. So when we push this, we adjust the stack. Okay. So I'm hoping people remember to check the other one for undoing the right number.
Right.
Okay. We compare the return value of string char to 0. So that, and then we, based on that, we perform a branch JZ to L3, but there's no looping here. So the only reason why we have no looping here is because this is a condition. So we're basically saying if this is returning a non-null value, or non-zero, whichever way you want to look at it, we do something. If it does return a 0, we branch around and do nothing. And then what we do in the condition here is we are just adding 1 to R. So R, you can write this whatever you want to, okay? R plus equal to 1 is fine, plus plus R is good, R plus plus is good, R gets R plus 1 is good. So just choose one, okay? And when we are out of the conditional statement, which is at label L3, we just add 1 to Q, okay? So plus plus Q, Q plus equal to 1, whichever way you want to express that is fine, okay? All right. So this is as far as we can do. Oh, okay, right here we move out of the loop. We move R into EAX, so R becomes the actual return value. So we just say return R here. There we go. All right, so we still have some types that we haven't really figured out. If people remember that in string char, the first parameter is going to be a const string,
Right.
that's fine. If you don't remember, you can just leave it as question mark because nothing can be implied by just this code here. I'm not going to count any points against people who leave this one as unknown. As far as R is concerned, it can be int. Okay, so we just int or unsigned. There's no indication whether it is signed or not. So as long as the return type of the function is consistent with the type of the local variable, it's all good. So are we doing okay so far with this code? Sort of?
I made it recursive.
You made it recursive? How? How does no call to itself?
Oh no.
But you caught most of the control structure stuff, right?
Yeah.
Okay. I think you just made a call here to itself.
No, instead of like making it a while loop, I just had to call F again, and then whatever, and then return to R.
Okay. Well, I'll check your code and see if it actually reflects the structure of the code.
I did make one mistake. Like instead of, I did if string char, then you go inside, do the R increment, and then did else Q increment.
Oh,
Yeah.
okay. Gotcha.
Yeah.
That's minor. It's all right. But that's the intended solution.
Yep.
All right. So moving on to the fun one.
Yeah.
Question number 4. All right. So question number 4 is giving you a particular subroutine already defined. Okay, XYZ is already defined with a local variable that has 4 bytes, and there's a string copy at the very beginning. And then there's some additional code to process whatever local puff has, which is these 4 bytes, assuming it only has 4 bytes. So it's not going to process anything beyond the 4 bytes. But the string copy does apply.
Copy will, right?
Sorry?
String copy will, though.
String copy will, because string copy does not end
Until it finds out.
until it finds a null, which is going to be a problem later on. I bit myself with this one. Okay. All right, so the first thing we want to do is to figure out on the stack, what does it look like? And I think to do this, the best way to do it is to use a spreadsheet. So I'm going to use a spreadsheet to do this part. Okay, discard. Okay. spreadsheet. Make it small. So, okay. So what we want to do is to say, look, by the time we do the string copy, what does the stack look like? That is the key, okay? All right, so we know it has a parameter, okay? So source as a parameter is on the stack, but this time I'm gonna break out so that each row is 1 byte, okay? And it uses the little endian convention. So when you have a multi-byte thing to do, then we just have to index it and go like, okay, source is going to take up 4 bytes. The least significant byte is going to be here, okay? So after the parameter is the return address, okay? So return address is going to take up 4 bytes too. So return address 2, return address 1, and then return address 0. Now, because this function is written in C, so it will follow all the same conventions that we have talked about in class, including push EBP the first thing in the subroutine call. So that means old EBP bracket 3, old EBP bracket 2, old, oops.
Is this based on the call to XYZ or STR?
This is based on the call to XYZ.
Okay.
And then we have OEBP bracket 0 here, okay? And below the OEBP is our local variable. So those 4 bytes that we are allocating for local buff is going to be right here. So we've got local buff 3, local buff 2, local buff 1, and local buff 0 will be here. Okay. So when you call the subroutine string copy, it is supposed to copy source, whatever source points to, only to these 4 locations, okay? If things work out the way they're supposed to, those are the only 4 bytes that should be changed. However, we are trying to overwrite these things or these other locations so that we end up calling the subroutine at this address. So the first thing we need to do is to fix the return address, so the return address becomes the entry point into this function. So we look at the return address. These are the 4 bytes that we need to modify. Okay, I think we need more rows. So let's make more rows. Okay. We might need even more than that, but that's okay. Okay, so what we need is the target address to be here, okay? And because this is little endian, so that means CA goes here, 04 goes here, F0 goes here, oops, and 08 goes here. Okay, if you forget the leading 0, of the 8, it's okay, not a problem. Okay, so this will redirect execute the flow of the program to the subroutine that I want to get into. So the next question is, once you get into there, it needs to have the right kind of structure on the stack, and that also means that we need just a little more than this. So we have 1, 2, 3, 4. Okay, because when you get into a subroutine, it expects certain things on the stack already. It expects the parameters on the stack. It expects the return address on the stack. Okay. Now, as far as the return address, which is going to be here, it can be anything. Okay, because my idea is just to get into the subroutine. Because by the time I get to the subroutine, I have already successfully hacked the program. It doesn't have to return clean up to that point. So I'm just going to make a whole bunch of FFs here. Okay, just doesn't have to be valid. Yeah, just anything. Well, almost.
Just no null terminators?
Exactly, which is going to be a problem later on. Okay, so we'll say combine these things and just say this is the fake return address. Okay. And this is the target location to go to. So the target address of the function that we want to quote unquote call. Now, when that function gets control, it is also going to assume parameters on the stack. So that means the parameters will go here and also here. The first parameter is the one with the lower address, which would be these 4 bytes. It needs to be a 1. This is the problem, okay? The 1 is not the problem. But then the other ones are going to be all zeros, which also means the copy is going to fail to copy everything beyond this point. Okay, but assuming that was not caught, okay, because I just caught myself during the test and they're like, okay, let's not do anything about this.
We'll just see what we get.
Right, and then this is the second parameter, so we need to push that on the stack as well. So that's going to be 0885 F6 FF and a BF. Okay, so that means from the perspective of the string, which starts here, it needs to specify this content. Is that okay? Now what you put into these 8 bytes, hey, it doesn't matter. As long as it's not null, everything is good. But since I made that mistake of requiring parameter 1 to have these null bytes to begin with, hey, if you specify null bytes here, it's going to be okay. I cannot fault you guys if I'm the one making that mistake in the first place. So that means when you look at from the perspective of local buff, okay, so let me write a new, make a new column here, okay. So from the perspective of local buff, which is going to be 0, 1, 2, okay, let me see if I can just number all these things here. It doesn't, when it goes up, it wants to decrease it. Okay, fine. How about this? This value plus 1. Take that. So that means we're gonna use all the way up to, and actually you need to extend this a little bit. Okay, so just copying these values. These 8 bytes, we don't really need to know what they will be. Okay, they can be anything. And then the next 4 locations has to be the target location here. And then whatever is after that, we don't really care because that's the fake return address. And then after that, we have the representation of 1 as a 33 integer, and then the address, which is the second parameter. So that's how it is, set up. Are there any questions about this one?
So since that shouldn't work
because of the null inside the
does that mean
1.
there's no way to actually really achieve this?
You are correct. There's no way to achieve this because one of the parameters needs to be a 1, and then you need to have those null bytes. So if this is -1, it'll be easy because they will all be FFs. So what I'll be grading on is just basically, do people understand that they need to overwrite what stuff on the stack, and also if they just give me this, okay, OEM, this is first param and this is a second param. If they just give me the right order, I'm gonna give them some partial credit. Just knowing the ordering of the first param, the second param, and the fake address in between the target address and the parameters, that's gonna be, there'll be some points for that.
So is that what the stack looks like before str copy is called? Or is that after it's called?
This is after.
Really?
After string copy is called. Before string copy is called, we don't know what these locations are because they belong to the previous call frame or the call frame that's calling me. But after this, this content needs to be on the stack by the time I get to the return instruction, and that's why whatever you overwrite here doesn't really matter. It's at this point that it starts to matter. So in other words, if you do end up with code where you want to get to a certain place, especially one without any particular address to go to, it's not really that hard to craft something because you can control the return address for sure.
I'm just trying to follow the logic of the method. So it creates that local parameter or that local variable, but then doesn't it call str copy and has to pop 2 parameters on the stack?
What is going to pop those 2 parameters?
Oh, is it the caller?
The caller is not, when you return, it's not returning to the caller anymore because I just packed these 4 locations. So it's when it quote unquote returns, it's actually jumping directly
No, okay.
to the subroutine that I want to
I
call.
understand that, but I just mean like when string copy, when it calls the function strcpy, it passes the parameter local buff and src. How do those? Don't both those have to get put on the stack to be called?
But that's going to be done on the other side. That's going to be done here.
Okay. And
So string copy is going to use up 8 bytes for its own parameters, and then string copy itself as a subroutine might use up some additional bytes. We don't know how many bytes it's going to consume, but that's on the other side of local buff. So it has nothing to do with what we want to achieve here.
okay. So all we were trying to do is get certain stuff copied to overwrite the stack for R.
Correct.
Okay.
So it really ultimately is a test to see whether people know how the stack is organized, but twice, because the first thing you need to do is to understand how it's organized for XYZ
Right.
and how the local variable is allocated. And then the second time is how it is organized from the perspective of the subroutine that starts at this location that has no name. Because it has 2 parameters, the first parameter needs to have a value of 1, and the second parameter needs to have a value of this junk here, which is an address basically. And also, it needs a fake return address. You need this space here to space out so that the called exploit subroutine will still get to the first and the second parameter correctly. Because without this, then it will look at the first parameter as the return address, and it will look at the second parameter as the first parameter. So it's not going to get the job done. Is that okay or?
Yeah.
Okay.
So like the program doesn't do any validation. It doesn't look at these bytes and say this can't be a return address. This is out of range.
Nope. Nobody's going to do any validation. This is C and C++. It's very trusting. It says, hey, if you want to overwrite this byte location, go ahead. So, but it all links back to the first part of the question though. The execution inhibit bit is useful because you cannot put code on the stack and expect it to run. But if your program has a place where it will do something nasty, like elevate privileges and do whatnot, and you find out what the address is, you can still control to a certain point where you return to. So it can potentially still be bad for anything that's security sensitive. But it's an application of what we learned in this class about how the frame is structured. As I said, most people did not really quite get this one. So most likely I would just count the highest scoring 3 questions out of 4, which
Probably will be the first.
I think most people would not complain.
Right. No.
But that's how the test goes. So are you reasonably satisfied, or okay?
It all makes sense now.
I just made minor mistakes. Like on.
I tried to design all of these things to have partial credit.
Right.
Yeah. So when I grade, I'm not going to look at what you turn in and go like, oh, you're missing 1 byte. All wrong.
No, I think on the 3, I renamed all the variables.
You rename all the
And I have them
variables.
back. Yeah, I didn't accidentally use R, Q, and S, or whatever the 3 were.
Okay. Well, then it depends on whether I can decode your answer or not.
I just wrote string count, essentially. I think that's what I read.
Oh, by the way, if you have not, I don't know whether you guys recognize or not. Do you guys recognize this one? It resembles a little bit of string f CPY.
Is that what
It doesn't do quite what it does. It counts how many bytes are filtered
Oh.
instead of actually copying. It has no destination to copy to.
Right.
But given because P is supposed to be a string too.
I thought it was just counting all the matching.
Yeah,
characters.
it counts how many characters
aren't 0.
would
right?
be copied if string f CPY is to be called. So it has a very strong resemblance as far as finding a null character and calling string char inside. That really should ring a bell to some people. It's like, hey,
Yeah,
we have done this before.
strchr will return an address as long as
It will return an address to the character, which is the second
Right.
argument, if it is found in the string, which is the first parameter.
Right.
If it is not found, it will
Returns
still
zero.
return an address, but it's going to be a null
Right.
address, which is all zero. But when you use an address as a condition, it follows the same rule as an integer. Zero is false, which means the null address is false.
Right. But anything.
And then
else is
everything
true.
else is true.
Okay.
So it follows exactly the same logic as if it is just an integer.
So essentially, it just ended up counting everything that wasn't null.
It will count everything in
Oh, that's
Q
right.
that is found in P
Right. That's why I
and
said
return
it
the
was-
sum.
Okay.
Yeah.
That's what I thought it was string count. You know, like passive.
Yeah, but I was trying to
to.
just reuse the logic of a homework assignment that you have done already, so that the structure of the code may look
Familiar.
vaguely familiar,
With one minor change.
with one minor change of the else, no, you did the else branch. But that's fairly minor. I mean, as long as you still see that it's a conditional statement, that's the major thing. Instead of it's a loop inside the loop of some kind.
But I think yours will just get stuck in the counting loop. Because if the first one, if it does, it'll never reach the else if it doesn't increment.
Yeah, the polarity of the branches is important too. Like it's continuing as long as Q points to a non-null character.
Right.
That part is important. So that's how I'm going to set up the grading criteria or rubrics, and then have to spend a lot of time to grade it.
You'll have fun with one.
I'm going to have
Because not everyone's gonna
fun
give you the
with
same
all
answer.
40, close to 40
Test.
tests. Yeah.
Is there another homework assignment after this current one?
I will probably give you guys one more, just so that you guys can kind of do a final boost of the points. And it depends on whether we get back to floating point numbers. If we ever get back to floating point numbers, I'll probably have one assignment on that one, just so that you can use the assignment to get a better understanding of floating point numbers. Okay. So I'm gonna stop the recorder. As I said, I cannot upload this one because somebody else